The final thing in this section is one solution problems. So absolute value equations always have two answers, but sometimes some of them do not work. So these problems, one solution problems, we will get two answers, but only one of them, when we plug them back into our original equation, will actually be true. So I only have one problem here because these take a little time because you have to work them out and you have to plug the answers back in. So let's take a look at it. We have the absolute value of 8 plus p equals 2p minus 3. Now, you'll notice something different here than what we've seen on the other problems. You have a 2p, or you have another variable on the other side of the equation. Most of the time, over here, you just have a single number, and the variable is inside the absolute value. But this time, we have another variable, another p. So that is your key or your indication that this is going to be a one solution problem. It's not always going to be a one solution problem. Sometimes problems like this that have the second variable will have two real answers, and sometimes there'll be no solutions. But when you see that second p, you know I'm going to have to plug my answers back in to see if it works. So let's work this just like we always do. First thing we look at, is there anything outside the absolute value? And there's not anything outside the absolute value on this left side, so we can go on and make our two equations. So the first one would be 8 plus p equals 2p minus 3. Remember, you just write it the exact way it looks. You just drop the absolute values. Now the second one's going to be kind of interesting. We do 8 plus p again equal to, now normally here we just make whatever the number is negative, but now we have two things over here, 2p and negative 3. So instead of making just the number, or just changing the sign of just the number, we now change the sign of both of these. So it would be negative 2p plus 3. Now we work both of these equations. So on the first one, we have p's on both sides. So we need to move all of our p's to one side. So I'm going to subtract a p from here. And I have 8 equals, and then 2p minus p would just be the 1p, or just p by itself, minus 3. Then we add the 3 over, and 8 plus 3 would be 11. So my first answer, or my first possible answer, is 11. On the second one, again, I need to get all my p's together, so I'm going to add the 2p over this time, because that'll make my math a little bit easier. And I've had 8 plus, and then p plus 2p would be 3p, equal to 3. Now I subtract the 8 over, and I get 3p equals, and 3 minus 8 would be negative 5. And then finally I divide by 3. And I have p equals, and then negative 5 divided by 3, you can just leave it as negative 5/3 because it's a repeating decimal. So we'll just leave it as negative 5/3. So there's your two possible answers. Now, in a normal absolute value problem, you'd be done. That'd be your two answers. But remember, because we saw that second variable, that second p up here, we know that this might be a one solution problem. So now what we're going to do is we're going to take both of these answers and we're going to plug them back in for the p's up here at the beginning. Now make sure you go all the way back to the beginning. Don't go back to these two equations. We split it. Go all the way back to the beginning. Okay? So we're going to plug them back in and see which one works. So let's try the 11 first. So absolute value of 8 plus 11 equals 2 times 11 minus 3. Now we're going to work both sides of these and then see if they're equal. So first, 8 plus 11, that would give us 19. So the absolute value of 19 equals, over here we do 2 times 11, that gives us 22, minus 3. Absolute value of 19 is 19, and 22 minus 3 would be 19 also. So that one checks out. So 11 works. So now let's check to see if the negative 5/3 works. So absolute value of 8 plus negative 5/3 equal to 2 times negative 5/3 minus 3. All right, so first up, 8 plus negative 5/3 would give us 19 over 3. So the absolute value of 19 over 3 equal to 2 times negative 5/3, which would be negative 10 over 3 minus 3. All right, so on the left side, we'd have the absolute value of 19 over 3, which would just be 19 over 3. And then negative 10 over 3 minus 3, which would come out to be negative 19 over 3. So you'll see right here, one is positive, one is negative. So those are not the same. So the negative 5/3 does not work. So our only answer is 11. So this is the only one. Once we plug it back in, that's the only one that works. So negative 5/3 wouldn't be the answer. So that's how you do absolute value equations. If you have any questions, let me know. Good luck.